Hello, I'm Shaun Thomas, and today I'm going to go over the 4.3-4 assignment for our graphics class. So first I'm going to run the program, and as you can see, we have better water physics and more splashing if you get the pen to move fast enough. So you can see when we have the pen in a corner, the water starts piling up like it would. So other particles start to stack on top of each other, um, depending on the tilt of the pen. So now I'm going to go ahead and walk through the code and my contributions to the program. So this is all of the code that we have, and then my contributions are towards the bottom. So the first contribution I have is this function resolve collision. Um, Here is we pretty much get the distance from equals, um, and then we vector math pretty much to determine how fast they need to move and if they're overlapping to prevent that from happening and how far we need to move them away from each other. Um, and then we check the velocity between the um, two particles, um, so that we know how much they need to, so we know how much impulse they have pretty much so that we can move them correctly and that we can simulate the physical bounce that will pretty much look like the water splashing. Um, and we have this variable right here, which is the splash threshold, which essentially indicates how fast the pen needs to move before you see splashes. Um, so that like slight movement of the pen won't cause all the particles to start splashing. Um, then here we have logic to randomly generate some particles inside of a pan, um, so that they fall inside the pan and um, so that they're not outside of the pan when they spawn, I guess. Um, and then the update method. So here's pretty much the splash logic. So what happens here is you have to get the magnitude of the pan moving pretty much. Um, and then if it exceeds the splash threshold right here, um, we pretty much select some random particles so that we can fire them uh, upward and outward to look like it's splashing whenever the pan's tilted beyond the splash threshold, which happens in here. And the direction of the pan tilting is where they would move. And then right here we have logic so that when particles overlap, um, we start stacking them instead of having them just be side by side. So that way it resembles water piling up in a corner when the water is tilted into a corner or if it's just tilted up or down. Um, so we can get the physics to make it look like the water is actually, that the particles in the water make it look like it's actually water instead of just dots that are in a certain area. So that's pretty much all the contributions that I had for the assignment, and that was our team's 4.3-4 assignment.